Tunguska object that exploded over Siberia in 1908 with the force of a 15-megaton nuclear bomb. The power of an impact on this scale is unimaginable. It would literally have set the sky on fire, produced global earthquakes likely and volcanism, produced extreme acid rain, and would have been followed by a temporary but intense cosmic winter due to the sheer volume of dust and soot injected into the atmosphere, blocking the sun. The scenario that evolved through many interdisciplinary studies as to the environmental effects of the KT impact was not at all unlike the vivid description in my little Viewmaster toy story that so captivated me way back in 1956. However, even as indirect evidence continued to mount throughout the 1980s in the form of impact proxies supporting the idea of an abrupt demise of the dinosaurs and a global ecological breakdown at the same time, critics refused to admit the possibility of cosmic impact without a smoking gun in the form of a crater, an impact crater. This changed, however, in the 1990s with the discovery and confirmation of a giant astrobleem or star wound buried under the Yucatan Peninsula that was of the right size and the right age. At this point, many of the critics were convinced. As studies continued on the extraordinary events at the KT boundary, it is beginning to appear that for a period of time, the Earth was undergoing multiple impacts during an episode of clustered bombardment, though the Yucatan strike appears to have been the most severe. It is also important to appreciate the fact that the Earth was, at the same time as this bombardment, undergoing, as we talked about, one of the largest, most extreme episodes of volcanism in the history of the planet, during which the so-called Deccan traps were extruded. So the traps are a massive deposit of layered flood basalts, originally covered as much as 600,000 square miles of lava that were up to 6,000 feet thick and encompassed as much as half of the subcontinent of India. Is it possible that the great eruptions such as the Deccan traps were triggered by the impacts of asteroids and or comets? This is a question that still needs to be answered, but it is almost certain the rapid extinction of three-quarters of all animal and plant species extant at the end of the Cretaceous period, including the dinosaurs, both marine vertebrate and invertebrate species, terrestrial plants, fish, insects, and primitive birds and mammals, was the result of both phenomena of cosmic impact and massive volcanism. When scientists talk about proxy evidence, they are referring to evidence which indirectly supports or confirms the hypothesis being tested. In the case of an extraterrestrial impact, this might be the increased presence of platinum group metals, such as iridium, osmium, or platinum itself. It can also take the form of nanodiamonds, that is, tiny microscopic diamonds that are formed in the extreme heat and pressure of an impact. Other microscopic level impact proxies include magnetic grains, microspherules, carbon spherules, soot, shocked quartz, and fullerenes. Mesoscale proxies, that is, material that can actually be held in the hand and seen with the naked eye, include tektites, melt glass, shatter cones, and sometimes pieces of the object, the impacting object itself. Shatter cones, I will mention, form in limestone rock as the shock wave passes through the rock, and it gives a very distinctive conical-like formation within the rock. Tektites are formed, they're exotic, aerodynamically formed objects that crystallize out of the fusion of melted, vaporized asteroid or comet material and the target rock as it falls back to Earth in a type of fiery alchemical marriage of celestial and terrestrial. So the impact vaporizes, melts and vaporizes. It adds its material to the target material, the terrestrial rock, this chaotic stew is mixed together, thrown up into the atmosphere, and when this stuff rains back out, it assumes a variety of aerodynamic shapes, and the composition of these forms is typically both the impactor itself and the target rock, melted and fused together. So the impact, the surface of the Earth is vaporized and melted along with the cosmic object itself, and an enormous amount of material is thrown out of the hellish cauldron of the crater into the atmosphere. As the molten material descends, it crystallizes, taking a variety of shapes such as spherules, teardrops, dumbbells, tubes, and flying saucers. Georgia, the state of Georgia in the USA, and the southeastern United States were blanketed by one of these cosmic torrents of molten material raining from the sky when an asteroid about 3 miles wide slammed into the eastern seaboard in what is now Chesapeake Bay about 35 million years ago. This impact, which left a crater more than 50 miles wide, very nearly marks the end of the Eocene epoch and a major turning point in the history of life on Earth. Tektites found in Georgia are called Georgiites and are found where the Eocene-Oligocene boundary is exposed at the surface. Just south of Macon, Georgia, along the so-called fall line, the Eocene surface is exposed, and if one knows where to look, tektites can sometimes be found after a heavy rain when they wash out. Now, at the time, you have to picture when this stuff is raining down on the Earth, the surface of the Earth, the landscape that was receiving all of this material, of course, is not the landscape any longer. Typically, it's going to be many feet underground. And so at the fall line, you have a slope, and heavy rains will cause the layering, going back 35, 40, 50 million years to get exposed. And right where that Eocene-Oligocene boundary is, there will be tektites laying on that surface that is now buried. And sometimes if you're there right after a heavy rainfall and the slope surface has eroded, you will sometimes find Georgia tektites. There is a display of them, or there used to be anyway, at the Fernbank Science Center near here in Decatur, Georgia. And they've got a very nice display of the Georgia tektites there. The occurrence of only one proxy at a particular site is not going to be enough to prove the occurrence of cosmic impact. However, when several occur in conjunction, it is strong evidence of an impact having occurred in the vicinity. In the case of multiple KT boundary proxies, they have been found on a global scale, signifying the magnitude of that particular event. Much closer to our own time, the major turning point in Earth's transition out of the Great Ice Age occurred very close to 12,900 years ago at the so-called Lower Younger Dryas boundary. This boundary coincides with the final extinction or the near final extinction of the great megafauna, the disappearance of the North American Clovis culture, and abrupt climate and environmental changes that have been documented from around the world. Since the year 2007, a series of impact proxies have been discovered at the Younger Dryas boundary, whose closest analog appears to be the KT boundary of 65 million years ago. The possibility of a major cosmic impact so recent in Earth history has given rise to one of the great scientific controversies of our time, one whose far-reaching implications are only just beginning to be grasped. So in the year 2007, a group of scientists led by Richard Firestone with the Nuclear Science Division of Lawrence Berkeley National Laboratory published an extraordinary article in the Proceedings of the National Academy of Sciences. In this article, they presented evidence that in the recent geological past, a mere 12,900 years ago or so, Earth was the victim of a major assault from space. The most likely culprit in their analysis was a comet. Now, if you would like to read the original groundbreaking article, see Firestone, Richard B. et al. In 2007. The title of the article is Evidence for an Extraterrestrial Impact, 12,900 years ago that contributed to the megafaunal extinctions and the Younger Dryas cooling. This article appeared in the Proceedings of the National Academy of Sciences, volume 104, page 16,016. Okay? The Proceedings of the National Academy of Sciences is public access, so you should be able to find the entire article available for free download on the web. Simply type in the title and you will be taken right to it. Go to Google Scholar. I haven't tried just regular old Google, but Google Scholar will certainly get you there. You can then download it, print it out, read it. The article has many valuable graphics and images of the discoveries made by the Firestone team. So the Younger Dryas impact hypothesis, as it has come to be called, is proving to be one of the most controversial scientific ideas of our time, not unlike the Cretaceous-Tertiary impact hypothesis when first proposed by Walter Alvarez and his colleagues back in 1980. Just as that idea generated extensive discussion with proponents and opponents of the impact hypothesis making their strongest arguments, so is the YD, or Younger Dryas impact hypothesis, generating vigorous debate, which is just as it should be in the practice of science. However, in this case, the impact idea has been met with a level of acrimony and disdain that considerably exceeds that of the earlier KT boundary debate. I'll get back to that because it is important to understand why the idea is so controversial. But basically, for now, the Younger Dryas impact idea posits that an extreme climate spasm that occurred at the very end of the last ice age, an event whose cause, at least up to now, has been an ongoing mystery, was triggered by the impact over North America of one or more cosmic objects, most likely a comet or its debris. This putative comet has been christened the Clovis Comet, after the name of a North American Paleo-Indian culture that virtually disappeared from the archaeological record at the very onset of the Younger Dryas. I will mention that the Younger Dryas, the fact that you call it the Younger, implies that there was an older Dryas, and what distincts these is they were initially applied to climate regimes. The Younger Dryas is named after a polar wildflower called Dryas octopetala, an 8-petaled flower that loves the cold. So in Northern Europe, you had the older Dryas, and Dryas octopetala was proliferating, and then it disappeared for a millennia and a half, roughly, and then it came back again, which seemed to indicate that the climate went from cold to warm, because Dryas octopetala does not like the warm climate, the warm weather, and they are going to quickly pack their bags and head north to where they can find the cold that they love so much. So you had the older Dryas and then the Younger Dryas. Now, the Younger Dryas appears to have been the more severe of the two, but in any case, since the idea was first presented in 2007, evidence both pro and con has accumulated. However, as of this writing, the case for impact has grown increasingly plausible, and with the publication of recent rigorous investigations, the evidence in favor of an extraterrestrial impact at the inception of the Younger Dryas now appears to be the most likely explanation for the extreme and inexplicable events that characterize the rapid transition of the planet out of the Great Ice Age.